Hello everybody. I am happy to welcome you all to this video lecture on Laplace transformation and its application. First of all, you have to see what is a transformation. A transformation is an operation which converts a mathematical expression to a different but equivalent form. A transformation is an operation which converts a mathematical expression to a different but equivalent form. Okay, I have an example. D by dx of e power x is simply present. What is this? E power x. Integration of e power dx is also what is this? It is an e power x. Okay, here we are using what is this? Differentiation and integration. Okay, in this topic we have to see what is the transformation. What is the Laplace transformation? The transformation is on what is this? It converts a mathematical expression to a different but equivalent form. Okay, we have to convert the mathematical expression to a different but equivalent form. D by dx of e power x is equal to e power x. It is d by dx is a transformation. The transformation is what is this? Differentiation. Okay, integration. The integral symbol is what is this? Integration. Integration of e power x into dx is equal to what is this? E power x. As the same as integration of cos x into dx is equal to what is this? Sin x. Okay, it is a transformation. Cos x is transformed into what is this? Sin x. Here we are using what is this? Integration. Okay, here we are to see Laplace transformation. Laplace transformation named after a great French mathematician Laplace, who used such a transformation in his researches in the theory of probability. The powerful practical Laplace transformation techniques were developed over a century later by the English electrical engineer Oliver Heaviside and were often called Heaviside calculus. Okay, what are the uses of Laplace transformation? It is used to find the solution of linear differential equations, as well as it is an ordinary differential equation as well as partial differential equation. It helps in solving the differential equation with initial values without finding the general solution, and then finding the values of the arbitrary constants and the boundary value problems can be solved indirectly. Okay, here we are using what is this? Already we know that how to solve the differential equation. There are a lot of types of differential equation to solve. Okay, type 1, type 2, type 3, etc. Something if it is going on. P, f of p comma q form. F of p comma q comma what is this? Z form. Already we know that lot of forms. And that form you have to find the singular integral, complete integral, and then what is this? General solutions, singular solution, complete solution, general solution, etc. In this Laplace transformation there is no need of that one. It is a classical one. We need what is this? Only the transformation. Okay, and the next, what is a Laplace transformation? Laplace transformation. Okay, first of all, Laplace transformation is an integral transformation. Laplace transformation is an, what is this? Integral transformation. Okay, and then Laplace transformation formula. Here what is the formula for Laplace transformation? What is the definition of Laplace transformation? Capital F of s is equal to L of f of t integral minus infinity to infinity f of t into e power minus st into dt. This is an bilateral form. Okay, and the next one is capital F of s is equal to L of f of t. This is equal to integral 0 to infinity f of t e power minus st dt. This is an unilateral or one-sided form. Maximum we are using that one. F of s is equal to L of f of t. L of f of t is equal to f of s. It is a transformation. L of f of t. What is f of t? Already we know that f of t is a function of t. Okay, f of t is a function of t. It is an input function. Okay, let the function f of t be continuous and defined for positive values of t. The Laplace transformation of f of t associates a function s defined by the equation. This is an equation. L of f of t is equal to what is this? Capital F of s or pi of s, f of s the whole inverse. Anything we have to denote that one. Here we are using what is this? L of f of t is equal to f of s. It is a Laplace transformation. It is defined by 0 to infinity f of t e power minus st dt. Okay, where capital F of s is the output and output of a function s, and small f of t is an input and a function of t. and e power minus t is the integral kernel, and the function s is and the function of s and t. kt already we know that it is a time domain. Okay, time function f of t, it is a function of t. Okay, s is, and what is this? It is a parameter. That parameter is it is a real parameter or complex parameter, anything. Okay, capital L is our Laplacian, our hero of this video. It is, and what is this? A Laplacian operator. Capital L is a linear operator or Laplacian operator. Okay, this is a definition of what is this? Laplace transformation. L of f of t is equal to capital F of s is a Laplace transformation. Okay, and the next is there are lot of transformation are there in our application side. Laplace transformation, Fourier transformation, is a transformation. Laplace transformation and Fourier transformation, both are integral transformation. Laplace transformation as well as the Fourier transformation are integral transformation. Laplace transformation is defined as Laplacian, Laplace, and Fourier transformation is who defined as what is this? Fourier. Okay, Laplace transform is a general case of Fourier transformation. FT is what is this? Fourier transformation. LT is a mother of Laplace transformation, is a mother of Fourier transformation. Okay, that is denoted by that one, it's a mother, and then what is this? Has daughter. Laplace transformation is a general case. Okay, in our universe, time is a king. In our universe, time is a king. Okay, in our universe, time is a king. Existence of here also the Laplace transformation also, time is a king. F of t is transformed into what is this? Capital F of s. Okay, here we are using Laplace. Okay, existence of Laplace transform, it's very very important. Existence of Laplace transform, existence, if it is does not exist means Laplace transform is it's not defined. Okay, f of t should be a continuous or piecewise continuous in the given interval, closed interval a to b, where a greater than 0. Okay, f of t means it is an what is this? Function of t should be piecewise or continuous in the given interval, closed interval a to b, where a greater than 0. And the second condition is, second existence of Laplace transformation is f of t should be of exponential order. Okay, what is a piecewise continuous? Already we know that the continuous and something piecewise continuity or piecewise continuous is, what is this? A function f of t is said to be piecewise continuous in the interval if the interval can be divided into a finite number of subintervals. Finite number of subintervals in such of which f of t is continuous. The limits of f of t as t approaches the end of end points of each subintervals are finite. Okay, what is the meaning of that one? Suppose the interval, open interval 1 to 2 or 2 to 3 or 1 to 10 is given, means here the end points are not included that interval. It is an open interval. Okay, already we know that a lot of intervals are there: open interval, closed interval, open closed interval, closed open interval, etc. In this open interval 1 to 10 is given, means 1 and 10 are not included that interval. Between 1 and 10 values are included, and the between 1 and 10 values, here each subinterval, so 1 to 2, 2 to 3, 3 to 4, and then 4 to 5, and 5 to 6, 6 to 7, 7 to 8, etc., 9 to 10. In these subinterval, in each subinterval it is continuous. Okay, f of t should be continuous on that interval. It is in piecewise continuous. Okay, this is a piecewise continuity. Okay, and then consider a function tan t. Okay, consider the function tan t. Okay, already we know that this is an tangential curve, tan theta curve. Already we well known that what is sin theta, what is cos theta, and then tan theta. Sin theta values and cos theta values, already we know that sin 0 is it is 0, sin pi by 2 is it is 1, cos 0 is it is 1, cos pi by 2 is it is 0. Same as tan 0 is it is 0, tan pi by 2 is it is an infinite. Okay, in this tan pi by 2, tan 90-degree values, what is this? Infinity values are occurring here, that one. Okay, I had to see that graph. 0 to pi by 2. 0 to pi by 2, what is this? Minus pi by 2, 0, pi by 2, we have an one curve. Okay, negative side 2, what is this? Positive side. And the same as pi by 2 to 3 by 2 have blue line curve. Okay, I see that curve. But the dotted lines of red line, pi by 2, 3 by 2, minus pi by 2, minus 3 by 2, or what is this? Here infinity were occurring. Here it is, and what is this? Discontinuity or there in this pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, etc. Here discontinuities are there. Here in this tan t, okay, it is a tangential curve of t, we have discontinuous are there. Therefore, the Laplace transform does not exist here. Okay, L of tan t is not exist. For the case of f of t is equal to tan t, the function is not integral on open interval 0 to t. For any t greater than pi by 2, and the function becomes infinite at pi by 2, 3 pi by 2, 5 pi by 2, etc. It has many discontinuous are there. Okay, in this tangential curve, there are many discontinuous are there. Therefore, L of tan t does not exist. It is not a piecewise continuous. Automatically, it should not satisfy the Laplace transformation. Okay, some elementary functions of a constant. Some elementary functions. First function is a constant function. Prove that L of k is equal to k by s, comma k greater than 0. K is a constant here. Okay, proof by the definition of Laplace transformation, L of f of t is equal to, already we know that Laplace transformation simply it is denoted by L of f of t is equal to what is this? F of s. F of t transformed into what is this? F of s. Okay, here we are using the Laplace transformation. Okay, given is on t, our answer is also what is this? It is not a t, convert into what is this? Yes. Okay, L of f of t is equal to 0 to infinity e power minus st f of t dt. This is equal to capital F of s. Okay, here we have to find the value of what is this? L of k. L of k is equal to what is this? K by s. We have to prove that. Okay, we have to find the LHS. We have to take LHS. L of k. L of k is equal to, and using the Laplace transformation definition, integral 0 to infinity e power minus st. Here f of t replaced by what is this? K into dt. Already we know that k is a constant, taking outside of this integration, k into integral 0 to infinity e power minus st dt. This is equal to k into e power minus st divided by minus s over 0 to infinity. Okay, already we know that the integration, or substitute upper limit minus lower limit, e power minus infinity goes to 0, e power 0 is 1. We get it is what is this? K by s. Here s is a parameter, therefore s is greater than 0 always. Okay, we get what is this? L of k is equal to what is this? K by s. Okay, this is a constant function. This is one of the first formula for Laplace transformation. L of k is equal to what is this? K by s. K is a constant. Suppose L of 1 is equal to 1 by s. L of 10 is equal to 10 by s, etc. And the next function is an exponential function. L of e power t, e power a t is equal to 1 by s minus a, provided s greater than a. Okay, we want to move on the proof. L of f of t is equal to, by the definition of Laplace transformation, just to write that one. L of f of t is equal to integral 0 to infinity e power minus st f of t dt is equal to capital F of s. Okay, and the LHS of our exponential function is what is this? L of e power at. L of e power at is equal to integral 0 to infinity e power minus a minus st. Just we have to replace f of t by e power at, e power minus st into e power at dt. Okay, in this integration, we have to take in common outside. In this 2 exponential form, we have one, what is this? It is a function of t. Okay, then just we have to integrate that one. In this exponential function, we have to take in common outside by minus, as well as we have to take in common outside by what is this? T. E power minus s minus a into t dt. Okay, just we have to integrate this that one. We get e power minus of s minus a into t divided by minus of s minus a. Here the function is, the integration function is what is this? T alone. Therefore, the remainings are constant. Here negatives are also there. Therefore, minus of s minus a are there. Okay, then I have to substitute the upper limit minus lower limit. upper limit is what is this, infinity, e power minus infinity is automatically 0. We get it is what is this, 1 divided by s minus a, s greater than a. Okay, then automatically we get it is what is this, e power at is equal to what is this, 1 divided by s minus a. This is a second formula for Laplace transformation. Similarly, we have to find that what is this, L of e power minus at is equal to 1 divided by s plus a, provided s greater than a. Okay, first one is a constant function, second one is what is this, exponential function. Next we have to see the same as it is an exponential function as well as the hyperbolic. Okay, what is this L of sin at? L of sin hat. L of sin hat is equal to a divided by s squared minus a squared is a formula. Okay, how to solve this one? How to prove this one means, proof, we know that L of sin hat, it is a hyperbolic function, already I told you that, e power at minus e power minus at divided by 2. Sin h theta cos h theta formula already we know that, e power theta minus e power minus theta divided by 2, as well as cos h theta is equal to e power theta minus e power minus theta divided by 2. If it is we have to in our theta we have to replace it by what is this, at here. First of all you have to find L of sin h at. L of sin h at value is what is this, e power at minus e power minus at divided by 2. That 1 by 2 is the constant taking outside, and then just you have to inside you have to multiply this L here, L of e power at minus L of e power minus at. Here we are using one of the property of Laplace transformation here, a linearity property. Okay, next few slides we have to see what is the linearity property. Okay, yeah, just you are inside you have to multiply that L value here, we get L of e power at minus L of e power minus at. 1 by 2 into L of e power at. Already we know that the first formula, the second formula, exponential formula, L of e power at is equal to what is this, 1 divided by s minus a. You have to substitute this value here. L of e power at is equal to 1 divided by s minus a, minus 1 divided by s plus a. And then you have to simplify this one, we get it is what is this, a divided by s square minus a square is greater than modulus a. Okay, then automatically we get L of sin h at is equal to a divided by s square minus a square, provided s greater than modulus a. Similarly, cos h at, L of cos h at equal to a divided by s square plus a squared, comma s greater than modulus a. Okay, which is enough. We have to see 5 formulas of Laplace transformation, and the next function is a trigonometrical function. Trigonometrical function means sin, cos, etc. L of sin at is equal to a divided by s square plus a squared, and L of cos at is equal to s divided by s square plus a squared, comma s greater than a. Proof, we know that e power I theta is equal to, already we know that this is an Euler formula, e power I theta is equal to cos theta plus I sin theta. Okay, here we have to find the value of L of cos at plus I sin at. Just you have to replace what is this, L of e power I theta. Theta replaced by the same as it is at. Okay, L of cos at plus I sin at is equal to L of e power I at. Already we know that L of e power I at, L of e power at is equal to 1 divided by s minus a. Here what is the values over there? L of e power I at or that, thus we have to replace 1 divided by s minus ia. Okay, already we know that in the denominator have a complex number or imaginary numbers are there, means imaginary variables or imaginary numbers are there, means we have to taking the conjugate of that, multiply and divided by the conjugate on that number. Here also the same process we have to do, 1 divided by s minus ia into what is this, s plus ia divided by s plus ia. And then we have to simplify this one, we get an answer, s plus ia divided by a minus b into a plus b is what is this, a square minus b squared, a squared is s squared, and ia the whole squared. I is an what is this, imaginary, I squared value is it is minus 1, therefore minus minus s plus, we get it is what is this, s squared plus a squared. Okay, and then we have to split that one, real and imaginary values, s divided by s square plus a square plus I into a divided by s square plus a squared. Equating real and imaginary parts, we get L of sin at. Okay, L of sin at is then what is this, imaginary value. Okay, then I write a divided by s square plus a square, and L of cos at is an real part. Then we get it is what is this, s divided by s squared plus a squared. Here s greater than a. Okay, these were the next two formulas for Laplace transformation. Okay, these are the one of the formula L of t power n equal to n factorial divided by s power n plus 1 or gamma n plus 1 divided by s power n plus 1. What is an n is an integer means we are using that formula n factorial divided by s power n plus 1. Otherwise we are using gamma n plus 1 divided by s power n plus 1. Property of Laplace transformation. Already I told you that the property, linearity property. First property, it is an initial property of Laplace transformation. Linearity property. L of a into f of t plus a it is b. Okay, just we are changing it as b. B into g of t is equal to, what is this? Just we are taking constant outside of this Laplace transformation. Already you have to inside, you have to multiply the Laplacian operator L. A into L of f of t plus b into L of g of t. This is equal to a into capital F of s. Already we know that Laplace transformation L of f of t is equal to, what is this? F of s. A into capital F of s plus b into capital G of s. It is a linearity property. And the linearity property physical meaning is, suppose if we apply the brake in a bike, okay, what will happen? Automatically the bike will stop. Is correct? Automatically the bike will stop. Otherwise, it is a linear property. Okay, we have to here we have to use we have one input. Automatically we get in what is this one output. Okay, here we are using what is this meaning of the situation as application of the brake stops the bike. This means that we know the output of the given input. This is a linear system. Application of brake may even cause the fall of the rider or some other accident. This happening cannot be predicted. This is a non-linear system. Okay, this cannot be predicted. Okay, this is a non-linear system. Generally, the Laplace transformation useful to convert the linear system into the non-linear system into the linear system. Okay, and the second property, change of scale property. If L of f of t is equal to f of s, then L of f of a t is equal to 1 by a into capital F of s by a. Okay, in the last we have to see what is the Laplace transformation. L of f of t is equal to simply present f of s. Here in this change of scale property, the function is also changed. Function is also and multiply by what is this? Simply have a constant a, f of a t. We get it is what is this? 1 by a into capital F of s by a. When the argument t of f is multiplied by a, then s is replaced by what is this? S by a in transformation capital F of s, and it is multiplied by what is this? 1 by a. It is a change of scale property. And the next property is shifting property. If L of f of t is equal to f of s, then L of e power minus at into f of t is equal to capital F of s plus a. And L of e power at into f of t is equal to capital F of s minus a. Change of scale property is what is this? In the function we have to multiply f of at. Okay, here it is shifting property is L of multiplication of two functions. Multiplication of exponential functions in the inside of Laplacian operator. Okay, L of e power minus at into f of t is equal to, automatically we get it is what is this? It is minus 80 or there. The answer goes to what is this? Capital F of s plus e. And then plus 80 or there. The answer goes to what is this? Capital F of s minus e. The Laplace transform of f of t multiplied by e power at is obtained by replacing s by s minus a in capital F of s, which is the Laplace transform of f of t. And the next is Laplace transform derivatives. If L of f of t is equal to f of s, then L of f dash of t is equal to s into f of s minus f of 0. L of f n dash of general case, L of f n dash of t is equal to s power n capital F of s minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0 or there, here it is. Okay, etc. up to f n minus 1 dash of 0. Here we are using that derivatives formula in application side. Okay. Okay, next example, evaluate L of e power minus 3t and L of e power 6t. Okay, Here we are using L of e power minus 3t means directly we are using the formula here. Directly we are using the general formula for Laplace transformation. And otherwise we are using directly by the formula. Okay, already we know that the formula for L of e power minus 80. What is L of e power minus 80? 1 divided by s minus a, exponential function formula. Directly we are using L of e power minus 3t means just we have to replace minus 3t. L of e power minus 3t means 1 divided by s plus a. A replaced by what is this? Directly 3. Then we get an answer. What is this? 1 divided by s plus 3. We have to check that one. What is that? Yeah, 1 divided by s plus 3. Directly we are using the formula. Otherwise we are using the general formula for Laplace transformation. Okay, directly we are using, it's very easy. Okay, L of e power 60. Here also the same. L of e power 80 is equal to 1 divided by s minus 3. Then I am using L of what is this? 1 divided by s minus a replaced by what is this here? It is 6. 1 divided by s minus 6 is an answer. Okay, simple problems for shifting theory. Shifting property. L of e power minus 3t into cos 4t. Here we have multiplication of two function. The multiplication of two function in exponential functions are also there. Okay, already we know that the solution is, already we know that L of cos at formula is s divided by s square plus a square. Here a replaced by what is this? 4. Then we get s divided by s square plus 4 square. Here we have to find the value of L of e power minus 3t into cos 4t. Yes, divided by, here we are using what is this? Shifting property. Here already we know that the property. Okay, I had to see this one. L of e power minus 80 into f of t is equal to what is this? Capital F of s plus a. Here also we are using that one. L of e power minus 3t cos 4t is equal to s divided by s square plus 4. Cos 4t value is s divided by s square plus 4 square. And then e power minus 3t are there. S replaced by what is this? S plus 3. This minus means we are replaced by what is this? S plus 3. If it is plus are there, we are using s replaced by s minus 3. Okay, just you have to replace s by s minus s plus 3. Therefore, we get an answer s plus 3 divided by s plus 3 the whole squared plus 16. It is an answer. Okay, I have some problems, so I have to do that one. Okay, and the next differentiation of derivatives, already we have to see that it is a differentiation of Laplace transformation. Okay, if L of f of t is equal to f of s, then L of t power n f of t is equal to minus 1 the whole power n d power n divided by ds power n capital F of s, where n is equal to 1, 2, 3, etc. In particular case, when n is equal to 1, we have to substitute n is equal to 1, the above formula, general formula, L of t into f of t is equal to minus d by ds of capital F of s. Already we know that. What is capital F of s? It is, what is this? L of f of t. Okay, and then n is equal to 2, L of t squared into f of t is equal to minus 1 the whole square, d squared by ds squared into capital F of s. Okay, this is a differentiation of Laplace transformation. The last we had to see the change of scale property, e power 80 exponential into something. If it is given means we are using that type of formula. T into something if it is given means we are using what is this differentiation formula, multiplication t divided by t. There are two types. The second one is divided by t. Integration of Laplace transform. If L of f of t is equal to f of s and the limit t tends to 0, f of t by t exists, then L of f of t by t, it is the formula. The above are conditions. Let me know that the given function is a Laplace transformation, so it satisfies the existence of Laplace transformation. Let me know that what is an existence? Piecewise continuous, automatically it should satisfy the piecewise continuous and exponential order. Okay, in this process, integration of Laplace transformation, one more conditions also satisfied. That condition is, what is this? Limit t tends to 0, f of t by t exists. Okay, here why that one? Here divided by t are there. If it is substitute t tends to 0 means automatically divided by 0. Divided by 0, it's not possible. It is an infinity value. Okay, on that purpose you have to check. If suppose divided by t is given means you have to check limit t tends to 0, f of t by t exists or not. Okay, if it is exist means you are using this one, otherwise it does not exist, you have to do. Okay, then L of f of t by t is equal to integral s to infinity L of f of t into ds. This is a formula for divided by t. Okay, for an example, L of t squared into e power minus 3t are there. Okay, here multiplication of two functions are there, t squared into e power minus t. T squared into e power minus t means we are using two ways. Okay, the first type is t squared into something means we are using this formula. Okay, here it is t squared into e power minus 3, t squared into cos t sin t means we are compulsory we are using that formula. L of t squared into e power minus 3t or the exponential form is also there, then we are using the first shifting property also. Okay, if directly we are using the first shifting property, we get an answer. Okay, otherwise we are using what is this differentiation formula. L of t squared into e power minus 3t is equal to the formula is what is this minus of the whole square d square by ds square into capital F of s. Capital F of s means what is this L of f of t. L of f of t is equal to what is this L of e power minus 3t. L of e power minus 3t value is what is this 1 divided by s plus 3t. Then we get a d by ds of minus, first you have to differentiate one time. 1 by x differentiation is what is this 1 by x square minus 1 by x square. Okay, minus 1 the whole square is 1. D by ds of 1 divided by s plus 3 is what is this minus 1 divided by s plus 3 the whole square. One time I have to differentiate, another time also I have to differentiate that one. We get it is what is this 2 divided by s plus 3 the whole cube, which is enough. Suppose divided by t are there, sin 2t, L of sin 2t divided by t. Okay, first you have to check it is a Laplace transformation or not, and the next you have to check what is this limit t tends to 0 f of t by t is exist or not. Okay, we have to check that one. What is f of t by t? Innermost of Laplacian operator is f of t by t, sin 2t by t. Okay, limit t tends to 0 sin 2t by t exist or not, we have to check first. Directly add substitute t tends to 0, sin 0 already we know that it is 0. Denominator also t tends to 0, we get it is also 0. This is an indeterminate form. If it is an indeterminate form, or that means we are using L'Hospital rule, the famous rule, L'Hospital rule. It is hold good for only for the limit. Okay, notice the L'Hospital rule. I had to differentiate the numerator as well as you have to differentiate separately by the what is this denominator. Limit t tends to 0. Differentiation of numerator is what is the sin 2t differentiation is 2 into cos 2t. Divided by t differentiation is simply represent 1. And then I substitute t tends to 0 here. We get 2 into cos 0 is what is this? Cos 0 is it is 1. Therefore 2 into 1 is 1. 2 by 1. 2 by 1 is it's also 2. Then we get an answer, we get a exist. Exist means we get in a finite number. 0 is also there. 0 is not possible. 0 is also possible. Infinite only it is impossible. Okay, therefore limit t tends to 0, sin 2t by t exist. Okay, L of sin 2t by t equal to, it is exist means next we are using that transformation integration formula. That integration formula is what is this? L of f of t by t is equal to integral s to infinity L of f of t into ds. Okay, okay, then I'll write here it is L of sin 2t by t is equal to integral s to infinity L of sin 2t ds. L of sin 2t formula already we know that basic formula 2 divided by s square. Here a is equal to 2 here, 2 divided by s square plus 2 square. 2 is a constant taking outside. 1 divided by x square plus a square, already we know that it is tan inverse of 1 by a into tan inverse of x by a. 2 into 1 by 2 into tan inverse of s by 2, and then I am substituting upper limit and lower limit. Tan inverse into 2 is cancelling. Tan inverse substitute. Tan inverse infinity is what is this pi by 2. S replied by s also. S replaced by s also in the lower limit, minus tan inverse s by 2. Pi by 2 minus tan inverse s by 2 is what is this cot inverse s by 2. Okay, it is cot inverse, which is enough. This is an answer. Okay, we have some of the formulas for Laplace transformation, basic formulas. So I have to see that formulas. Sin 80 cos 80 k is here. Cos square h 80 e power 80 e power t into 80, all the formulas are there, and using that formula in our Laplace transformation. Okay, and the next we want to move on the inverse Laplace transformation. In order to apply the Laplace transformation to physical necessary to invoke the inverse Laplace transformation. If L of f of t is equal to f of s. Okay, L of f of t is equal to f of s, already we know that it is a Laplace transformation. Then the inverse Laplace transformation is denoted by L inverse of f of s is equal to f of t. Okay, just we have to replace that L goes to another side. We get it is what is this? L inverse of f of s is equal to f of t, t greater than 0. Okay, already I told you that it is a transformation. Transformation is what is this? Already I told you that that a transformation we have to transform what is this? Mathematical expression to a different but equivalent form. Okay, mathematical expression to different but equivalent form. Okay, here also the same process. L inverse of f of s is equal to f of t is the inverse Laplace transformation. Here time is a domain in what is this? Domain is domain f of s is changed into what is this? F of t. Okay, Laplace transformation f of t is transformed into what is this? F of s. Here f of s is transformed to what is this? F of t. Here L inverse is an inverse Laplacian operator. It is also linear operator. It satisfies all the formulas and all the properties of Laplace transform also. Similarly, all the properties and then elementary functions as well as formulas as Laplace transformations. Okay, it is also the last. Already I told you that just like this one, we get an Laplace transformation, inverse Laplace transformation formula. And then last topic of this one, applications of Laplace transformation. The Laplace transformation technique is used to solve system of differential equation as well as what is this ODE and PDSLS and integral equations also. Okay, Laplace transformation, it's very useful application, very useful what is this law system of linear differential equation to solve the system of linear differential equation, ordinary as well as PDE. Okay, partial differential equation. Advantage of Laplace transformation, it gives the particular solution directly. This means that there is no need to first find the general solution and then evaluate the arbitrary constant as in the classical approach. Okay, already I told that here we are using only the what is this directly we are using the transformation. There is no need of singular solutions, complete solutions, and what is this general solutions are there. Okay, and also same as in the ordinary differential equation classical approach, we have to solve the ordinary differential equation. Means first of all you have to find the complementary function, and then you have to factorize this one. You have to find it is real or complex roots, etc. You have to find the what is this first step you have to find the auxiliary equation, and then you have to find the factorize that one. We get to the complex what is this CI, it is a complementary function, and the next you have to find the particular function, etc. There is no need of that way in this Laplace transformation. Large number of differential equation also we have to solve that one. Okay, it is an advantage of Laplace transformation. Application of Laplace transformation in science and engineering fields, analysis of electronic circuits. Okay, Laplace transform is widely used by the electronic engineers to solve quickly differential equation occurring in the analysis of electronic circuits. It's a main major application. It's a main and major applications of electronic students. Simple electric circuits and complicated electric circuits solve easily by what is this? Easily by using what is this? Laplace transformation. Okay, system modeling. Laplace transformation is used to simplify calculations in system modeling where large number of differential equations are used. Okay, in the system modeling we are using lot of circuits are there, and the type of large number of differential equation easily we are to solving what is this? Easily we are to solving here we are using what is this? Laplace transformation. Digital signal processing, one cannot imagine solving digital signal processing problems without employing Laplace transformation. Digital signal processing we are to using mostly we are using what is this? Laplace transformation. In nuclear physics, in order to get the true form of radioactive decay, a Laplace transformation is used. It makes easier to study analytic part of nuclear physics. Okay, growth decay method, in all the method of what is this decay, radioactive decay, growth decay method, all the methods, we have planetary motions method, in all the methods directly or indirectly we are using what is this? Laplace transformation. Okay, these are the applications of what is this Laplace transformation. in analysis of electronic circuits, system modeling, digital signal processing, nuclear physics, etc. There are a lot of experience, lot of applications are there. Okay, I had to solve on a simple problem of what is this, ordinary differential equations. Application problem: solution of linear ODE, solve dy by dt minus y is equal to e power t, comma, the initial condition is given y of 0 is equal to 0. Okay, solution is just we have to replace dy by dt can be written as what is this, y dash of t. Y dash of t minus, why you have to write it as y dash of t? Okay, already we know that Laplace transform contains a domain is what is this, t. Okay, f of t, that is f of t or y of t is equal. Okay, dy by dt can be written as it is y dash of, it is a function of t or that, then we have to put it what is this, y dash of t minus y is also replaced by what is this, y of t is equal to e power t. Comma, y of 0 is equal to 1. Just we have to replace the given equation by normal form. Okay, taking Laplace transformation on both sides, L on both sides, Laplacian operator on both sides. Okay, L of y dash of t minus y of t equal to L of e power t. On both sides we are to taking L on both sides. Okay, and then already we know that Laplace transform and inverse Laplace transform, what is this, satisfies the linearity property. Then automatically I write L of, just inside I have to multiply that L of y dash of t minus L of y of t is equal to L of e power t. Okay, already we know that derivatives of Laplace transformation formula, and using that formula here, what is that, L of y dash of t is equal to S into L of y of t minus y of 0. Minus already there in our problem, minus L of y of t equal to L of e power t value, already we know that L of e power a t is equal to what is this, 1 divided by s minus a. Here L of e power t are there, then we get it is what is this, 1 divided by s minus 1. Okay, y of 0 is equal to, already we know that the initial condition is 1, and then I had to substitute that one, L of s into L of y of t is equal to minus 1 minus L of y of t equal to 1 divided by s minus 1. Okay, in the first term and then last term, the first term and the last term we have what is this, L of y of t. The minus 1 is a constant, and then I have to get into another side, right hand side, we get it as what is this, 1 divided by s minus 1, minus 1 goes to, we get it as what is this, plus 1. Okay, L of y after taking common outside, we get it as what is this, s minus 1. Therefore s minus 1 into L of y of t equal to, then I have to taking simplify that one, 1 minus s minus 1 divided by s minus 1 plus 1 minus 1 is cancelled, get s divided by s minus 1. Therefore L of y of t is equal to, s minus 1 is here in this left hand side, s minus 1 is multiplication there, then move on to right hand side, we get it is what is this, divided by, okay, L of y of t is equal to, we get an answer, s divided by s minus 1 the whole square. Okay, what is the aim of our differential equation? We have to find the value of y. Okay, okay, we have, first of all we have to find what is this, first we are using what is this, taking Laplace transformation, and then we are using the differentiation formula, you have to simplify that one, you have to find the value of what is this, L of y of t is equal to s divided by s minus 1 the whole square. Okay, okay, I had to solve this one, you have to find the value of what is this, y of t. Okay, s divided by s minus 1 the whole square. Okay, in this Laplace transformation elementary functions and formulas, there is no need of s minus in the denominator, s minus 1 the whole square, etc. are there. Okay, and that purpose we are using the partial fraction method. Already we well known that partial fraction method, we have to simplify that one, we have to split that one. Okay, 1 divided by, using the partial fraction method, we get it as L of y of t is equal to 1 divided by s minus 1 plus 1 divided by s minus 1 the whole square. Okay, automatically you are right, y of t is equal to, you are using the inverse transform also. Okay, y of t is equal to L inverse of 1 divided by s minus 1 plus L inverse of 1 divided by s minus 1 the whole square. Already I told you that in the Laplace transform and inverse Laplace transforms it satisfies the linearity property. Okay, and the purpose inside I have to multiply that L inverse here. Okay, already we know that L of e power a t, elementary function formula, equal to what is this, e power a t. L inverse of 1 divided by s minus a is equal to, it is e power t. Here also plus e power t into L inverse of 1 divided by s squared. Here we are using first change, first shifting property here. Okay. Okay, automatically 1 divided by s squared, L inverse of 1 divided by s squared is e power t. Therefore e power t plus t into e power t. Then we have to take a common outside by e power t, we get it is what is this, y of t is equal to e power t into 1 plus e power t. It is enough. This is an solving process of ordinary differential equation. Okay, here we are to using all the above slides in one of the linear ordinary differential equation. In one problem, and using all the other what is this differential what is this Laplace transformation, inverse Laplace transformation, and then all the elementary functions, all the formulas, etc. Okay, it is the application of Laplace transformation. It is how to how to solve the linear differential equation using Laplace transformation. Okay, which is enough. And the last, what is the real life or real time applications of Laplace transformation? Semiconductor mobility. So one of the most famous applications of Laplace transformation, semiconductor mobility. Call completion in wireless networks. Okay, call completion in wireless networks. Vehicle vibrations on compressed rails, and the behavior of magnetic and electric fields above the atmosphere. Okay, these are the real-time applications of Laplace transformation. Okay, thank you very much. Thank you.